Hi CS109 staff. So I wanted to provide an overview of the code, which is something I couldn't really provide in my write-up. And so to start, my project is on NBA players and how to predict using a naive Bayes model classifier their points. And the idea of my project was going to be based on just my interest in NBA player hot streaks or cold streaks. This is like a phenomenon known in the sports world where a player is doing really, really good for a certain amount of games, and then you can expect them or maybe to do much better in their next game. And if a player is doing really, really bad, you could expect them maybe to probably do worse in their next game. So I wanted to explore this phenomenon because many people believe that it's just a myth, but also I think more people believe that it is a true psychological phenomenon that it happens, and players just naturally just when they're playing really, really good, they just are on fire. That's what they can call it. So first, some of the models or some of the libraries I added, most importantly, was probably the NBA API. So the NBA API is how I obtain all my data. And basically I I coded up an NBA web scraper. And basically this NBA web scraper just obtains all the players from NBA.com and then puts them into a list. I filtered out a lot of the players who don't get minutes because they weren't really worth investigating because they don't play in any games. And then essentially what I did was for every single player they have their own specific ID. I added their game logs to a dictionary, and well, their game logs look something like this, just games with a lot of stats like points, assists, rebounds. In this project, I'm only concerned about points, but yeah, we can see all like their game logs, and basically we can just add them to a dictionary so we can associate each player with their games. And then now here's the step about how we generated our data and prepared it for the act of naive Bayes classification. So what we did was we wanted to use CSV files. So the idea here is to represent streaks. We have a window size. So a window size represents like an interval of like X consecutive games. Each game receives a feature of 0 or 1, and it's going to be 0 if it's under the player's season average, and 1 if it's over the player's season average. So and the Y value is going to be basically if the game right after the window is above the season average. So we see here, we basically go through a loop of interval of window size, and then append this to our data sets, and then we split using a train test split to get we set 20% to be the test data, and then this is how we create our training and test data. And most importantly, this is how we prepare it for naive Bayes classification. So we see all these CSV files of train and test, and then we can see here like what these train and test data look like. So it's 1, so this player got over their average, and then et cetera, et cetera. And then now for a naive Bayes classifier, I explained the math within the write-up, but essentially this classifier is just a modification of the naive Bayes classifier I wrote for my P set, and we have our Laplace estimation here to account for any possibility where there's 0 games above the average. And yeah, essentially we just run naive Bayes classification to find the maximum posterior, or the value that maximizes the posterior, and we predict using the functions that were helped written for us and by the staff. And yeah, I used essentially just the model from the P set and obtained some really interesting data. So just for example, for 10 games, we got a total accuracy of 0.51, which actually happened to be the lowest. And you can see all these players and the graph of their accuracies. And more of the graphs are in the write-up. And thank you for listening to my project, and I hope you guys enjoyed.